Good morning. How's everybody doing this morning? Welcome to installment number 9 of the COVID series we've been doing. We've been using our new training benches to try and show you some error scenarios, some different meter forms, some different meter services. Today, we are doing We are going to be talking about substation metering. So we'll be connecting a PowerMaster 7 series to primary service. We're going to be verifying connections, running a phantom load test. We're also going to be running a CT test. And we'll be using the 8016 or high volt probe that Powermetrix has. So we're going to be using the high volt probe. We get a lot of questions about that, so we'll go over the actual connecting up the high volt probe, how to use it out there in the field, and then we're going to show you some stuff about a panel mount. Okay, Chris is going to go over a panel mount meter. All right. So before we get rolling, let's offer up a quick word of prayer, and then we'll jump into it. All right. Precious Heavenly Father, thank you so much for this day. It's a beautiful day here in Knoxville. I know some folks like my buddy Sam in Ohio is saying they just got snow recently, 3 inches, but here in Knoxville it's beautiful, Lord. And in the midst of all this, if you just stand out there and look at what a gorgeous day it is, I hope that we understand what that means, that you are in control, Father. And I know we're going through a lot right now. It's topsy-turvy, but it looks like we're starting to see the light at the end of the tunnel. And Father, you're in control of everything, so you've been in control of this. So we just lift up and ask that you watch over all of our family and friends and just watch over us and make sure that we're safe. Watch over all these folks that are on this webinar right now. A lot of them put themselves in harm's way for people and to serve others. And watch out for them, Lord, just like all these healthcare workers. They've put themselves in harm's way to serve all of us. So, Father, just watch out for those folks and keep your hand on them and watch us today and help us to get through this. So hopefully we can teach something to some folks to help them be a little bit safer out there in the field, Lord. And most of all, thank you for your Son. Without His sacrifice, I couldn't even be praying right now. So, Father, thank you for Jesus. And that's who I'm asking and saying all things according to is my brother, Jesus Christ. Amen. Let's roll. Okay. So the first thing that we're going to do here is we're going to talk about testing we have a 9S meter here. You can see that it is a typical substation meter, square ion meter here. And we're going to test it. Now, some things we got to keep in mind. Is there a way you want me to talk? Are you here? Oh, I'm good. Okay. Now we're doing substation testing here for testing meter. So what happens there? We know that we want to isolate. We have to open up everything because if I were to leave everything connected at that test switch and I accidentally got some, if I got some that went back into the system, okay, and I could trip a relay, we'd have a serious problem. Okay. You start seeing hard hats you don't normally see showing up at the substation, want to know what's going on. Okay? So we definitely don't want that to happen. So we typically isolate, right? So we're going to open up our voltage switches and we're going to provide the voltage with the test kit. Okay? And then we will run a phantom test on the meter. And when we run the phantom test, you're going to see it here in just a minute. Normally when you run a phantom test, especially out there in the field distribution, you use the potential there at the site. So you would leave the setup with 0 volts. But when we're at a substation and we're going to open everything up, now we supply 120 volts with the test kit. So it looks like a little different setup because I've got to put 120 volts in that column for voltage in my phantom load setup. All right? So we're going to talk about all that as we go along. But first of all, let's look here at the, if you can see right here, and Jared will let me know if I'm not view or in view or whatever. If y'all can see the wires laying on this floor, you'd understand. I'm being careful because if I crash something, Jared's going to kill me. Okay. So if you're looking at this, you can see right here, I've got my pickup right up here, okay? So I'm using my pickup because you can see right here, you see where it's labeled watts. I don't know if you can see that or not, but watts are right there by that where I'm making my pickup, where I've got it here. It says watts right here. That's because that's what I'm measuring, right, is watts. So I should be over here. It's VARs over here on the other side, watts on this side, okay? So I'm connected there. Now, I could use, in some cases, they still use KYZ pickups, okay? K is the common there. I got my YZ contacts. So you've got a relay board there, and I use a KYZ pickup. You can see I've got these small easy hooks that I use to make my connections. So we do have the pickup for that if you do need a KYZ pickup, all right? We're going to go with the standard blue snake on this one. So we've got the blue snake connected up here. Now let's talk about what we're going to do here at the test switch, okay? So remember, I'm running a phantom load test, but this is a little bit different. I'm going to be opening up and isolating at that voltage, okay? So what I'm going to do here is my voltages here, here, and here, okay? So after I've opened those voltages up, I'm going to come in here and make my neutral connection. And I come in here and I go ABC, red, yellow, blue. We know what our phasing is. So to get a better grip, let's talk about this for a second. You can get up on the top tabs up there at the top, but if you think about it, hope you can see this. So I'm grabbing onto this thing, and if I get any pull at all because of my cables, I tend to make just a couple of contact points on that top tab. So instead what I'm going to do is I'm going to grab right here on the jaw. So I'm going to come in here and go red, I'm going to go yellow, and I'm going to go blue. So I'll make my connections there rather at the top. Because remember, like I told you, when you connect up here at the top, see how it wants to pull down? So I would rather go in right here and get on that jaw. Okay? So now remember, I'm doing a phantom load test. We've talked about this before on doing a phantom load. Okay, so what I'm doing now is I'm driving the current with my duckbills. Okay? I'm driving, remember, for our duckbills, it's in the white, out the black. So it's out the black and in the white. So I'm going to be driving the current out at the bottom here on the black side of those duckbills. Okay? So what I'm going to do is, I'm going to leave these connections. I left them there so they'd make it a little bit easier. Less of a chance of breaking anything. So what I'm going to do is I'm going to shunt. Okay? So I'm going to shunt those CTs, and then I'm going to come here and remember, the flow is I'm going to drive my current black at the bottom of the duckbill right here. I'm going to hit right there where this gray easy hook is. I'm going to come through here, and I want to come in the top over there on A phase. So what happens is my current hits here, and it runs up here and goes into A phase right here, goes through the meter, and then when it comes back through here. This is kind of a crazy test switch. You see how it is. I've got all my returns over here, and you can see how I've got it set up here. So it's kind of crazy. This is actually one that's, that we put together. This is a custom deal we put together for a customer of ours. So this is their can, their color. So you can see it's a little bit different here. So I have to come from here, but it's still the same theory, okay? I'm coming from the bottom. Remember, I've given y'all hints like that in the field before. You have to get around the long blade at the bottom to make your bottom connection. So I'm making my connection here at the bottom of the return switch, and then on that same phase, I'm coming up here to the top of the shunt blade. So it comes straight up through the top of the shunt blade into the meter, and then back down through the white, coming back to my test kit. Okay? So I'm going to do the same thing with B phase. And I'm going to come in here, C phase. Okay? So now I've got all three of my phases are set up so that I'm going to, my current's going to hit here at the bottoms, it's going to come over and it's going to go in the meter and it's going to come back through the white, it's going to come back into the test kit. Okay? That's how we're going to make the connections. So now remember, I'm driving here, so I'm going to be supplying the, so I'm going to look here at this test. You see I'm supplying 120 volts. So if you look here, I'm going to hit 3, and let's talk about that just for a second. If I went through an integrated site test, okay, remember the order that my integrated site test goes in is first it does a customer load test, then it does test the CTs, then it tests the meter. So if I chose the integrated site test right now, it would go to the CTs first. And I wanted to show you the meter first, so that's why I'm going to meter testing here, okay? And we talk about, just real quick, you know, we talk a lot about, for us anyway, and me personally, I like the customer load test because it takes everything into account. But in this case, of course, we don't have that, we can't do that here at the substation, so they're always going to want you to run a phantom load test. So because of that, I can't run that customer load test first, so I'm going to wait and I'm going to jump down here and hit this. Normally, throughout this series, I've always used the integrated site. I just wanted you to know that's why I'm going to the meter testing on number 3, is because it would want to do the CTs first. So I'm going to go to number 3. I'm going to do a phantom load test, number 2. Okay, so here we're going to run the test where you can see that's not the one we want to run. Hold on a minute. We want to go to here, page down. I've got one created called bench. See what bench looks like. Yep. So I've got bench. I created this test. Let's look at some of the things I did on this. Okay, and I know this is a review for a lot of folks, but for some it might not be. When you go in to set these tests up, the columns that we're interested in are, let's look at the label one first. I've set it up for a full load, power factor, and a light load. And to change any of the cells, by the way, you just hit this button, the drop-down button, to open up the cell, enter what you want in there, and then hit the button again to close the cell. So that's what I did, and I just picked out full load for my first one, power factor for my next one, and then light load for my next one. And then I came over here, and here's where the difference is for the test we're doing today. I didn't leave that as 0 volts for my voltages. I changed those to 120 volts for all 3 of those, because I'm providing the voltage now. And then it's 2.5 amps on the full load test, 2.5 amps on power factor, and remember, always 1/10 on the light load, so it's 1/4 of an amp here. And then my power factor is going to be 1 for both my full load and light load, and then it's going to be a half, 0.5 for my power factor. So I don't want to make a bad power factor, right? And then you'll notice over here I dropped my pulses down a lot just for expediency's sake for what we're doing today. So I've only got 2, 2, and 1 on my pulses. Okay?
Maybe when I talked about the bidirectional meter.
There you go.
You can do delivered and received
Yeah.
as well.
Great. So that's good. Sorry, I should have said something. So over here under flow, you've heard me talk to you guys before about, let's say we're out there testing some solar. And so we would change that from delivered to received. Okay? I'll go into it real quick just to show you. Remember, you hit this button to open it up. No, it won't, because I've got it locked in. But if you hit that button and you were setting up a test, or if I hit the edit button and did it, I just want to show you guys this. Okay, so if we look at it now, should be able to go there. Here we go. So I can do delivered or received. Okay, now if I'm out there at a solar farm I'm testing, I'm going to put it on received, right? And if it's a bidirectional meter, then it should come out correct where you'll have positive registration. Remember, we had an issue earlier in the series where we didn't have a bidirectional meter, so it couldn't pick it up.
In this case, where you have both, where this meter can measure both watts and VARs, you can also create more lines, more tests, up to, I think it's 16.
Mm-hmm.
You can do up to 16 tests in one setup, so you can actually run 3 watt-hour tests, full load, power factor, light load, and also do a VAR test immediately after. And the nice thing about this particular meter is that you don't have to change the programming for your VAR measurement. All you have to do is just move your pickup over to the VAR pulse, and then go ahead and move forward.
And another thing to what Chris is saying, that's a good point, is we have some people who do it by element. So you could actually, I've seen them stretch it out where you got just A's, just B's, and just C's and do it individually like that. So that's why you can set up several rows on these tests, okay? All right, so here we go. We're going to start the test now. We're going to start up the load box, check for valid signals, make sure everything's okay. You can see the meters coming on over here. You can see we're getting power to the meter. It's always going to go through its checks, and you've heard me say this before. When it's sending this stuff out, one great thing, Jim and I ran into this down in Florida, it's going to send out some VA and look for some coming back. And if it doesn't get back the right amount, it's going to say, wait a minute, I either have a loose connection or something's, I don't, typically it's going to be a loose connection. I've got way too much resistance there. So what it's trying to save is it's safety for personnel in case someone's leaning against a box and you crank up a load box. It's also safety for the equipment. We don't want to damage our load box on the equipment, okay? Okay, remember I had set this up for, I got way fewer pulses than you probably normally run out there. But you could just, and that's all in the setup. Whenever you set it up, you're going to set up the number of pulses that you want in there. We hear everything 10, 5, 2, 2, 3, 3, 1. But, and most of the time, when we're in there, especially if you've purchased new equipment, we spend a day there on site with you, training you. And that's one of the things we do is set it up. So we'll set up a bunch of tests in there so they're already set up. With the Powermetrix equipment, you know it's the setup on the front end, and once it's in there, it's just in drop-down boxes, and you can just go to it. Okay, you can see on this piece of equipment right here, I've done a lot of testing on it. It's probably time I took some of it off of there, and so all of it's in there, and I can just hit drop-down boxes and access any of that information. Okay. So you can see I had it set up for 2, 2, and 1, so I got my 2 pulses on my full load, and this meter is 0.2% accurate, so we're okay there. So it's giving us green. If it fell outside of that, it would give us a red and tell us we got a problem. Remember, Powermetrix were green's good, red's bad. And now, like always, we're out in the field going, come on, light load. Say they see this one too, or are they just looking at that one? Okay. Cool. While that light load's running, I just want to talk about this one more time on these connections, because this is where, a field guy just like y'all. So when we get out there and do them, when we start putting these jumpers on, with this one being a little bit odd, and I've got my, my returns over here, and then I've got my shunts way over here, you just got to keep in mind, I just want everybody to keep in mind, you're going on the same phase. You're going to connect at the bottom of the return blade and the top of the shunt blade. Remember, I've given this pointer out there in the field. The long stroke blade is always going to be your return blade. The shunts are a little short stroke. So if that long blade is always going to get in your way to make the connection at the bottom. Okay, you're always having to get around those. So you know the long blade or return blade is where you're making your connection at the bottom on that phase. Then you go to the top at the shunt. Okay? And I like the little jaw thing. Chris gave me a little pointer on that one. I like it versus those trying to get on those tabs at the top. The jaw with the alligator clips works a lot better. Okay? All right. So we ran through the full load, the power factor, and the light load test. You can see I'd set it up for 221. And so that's what it did. It ran 221. Everything fell within the acceptable parameters and range that we had set up in the test kit. So it gave us green numbers and said everything was okay. So then when we finished there.
But if there's anything they didn't like, they can always...
This orange bar and hit the retest button.
Okay. Okay, the earlier stuff was some good suggestions. Now you're just backseat driving. Okay. Is my mic still on? Oh, okay. Anyway, no, thanks for that one, Chris. So, yeah, you can move the gold box. It's the same when you do the CT tests. If you need to adjust your flexes a little bit on one of them, and so you got a pass, fail, pass, you want to go back to B phase, you just come back to B phase and you would retest that. In this case, if one of these tests you wanted to retest, you just hit retest. It will just test what's in the gold box, and then if you hit retest all, it'll retest all of them. So we are going to hit done. And when we hit done, remember it date and timestamps and saves it in there so that you'll have it to show the customer. Yeah, but you want to show some slides?
Show that after.
Oh, after the connections of this? All right. Let me get these out of here. So now we're going to run CT test. So to do that, we remember we're going to have to throw our shunts back in. I was going to tell you you're missing some current. So we're going to throw those back in. Okay? So, thanks, Jarrett. Let's talk a little bit about the high volt probe. Okay, we have the base unit here, okay, and the base unit is connected to my probe adapter cable with my signal cable. That's what we call the signal cable right here. And if you've heard signal cable, you might have heard it because when you have a new piece of test equipment but an old high volt probe, can it work? The answer is that yes, it will if you have one of these signal cables. So see, here's where we got the chip in there to calibrate. Okay, so as long as we got this chip in here and can calibrate it, then that way we can calibrate it even with an older high volt probe, a new piece of test equipment. So a lot of folks say, do I have to buy a new high volt probe? Nope, all you need is a signal cable right here. Okay? Now notice that we've got it on A phase. I've had guys call me up when I'm rolling down the road going, hey man, it tested fine on A phase, but B and C phase wouldn't test. And the first thing I ask them is, did you move the connection over to B or C phases? And they'll say, well, yeah, because I tested A phase, then I went to test B phase, so I moved the connection. You don't move the connection right here. You leave it on A phase the whole time. Okay, you don't connect it there. You leave it right here to test A phase, B phase, and C phase. The only thing that moves is the actual high volt probe. Okay, the connection doesn't move. All right, so you come from here, and you come from your probe adapter cable. You connect right in here to the face of here, right? And then you get your fiber optic comes in right here in the top. Okay, so you just put the fiber optic in right here in the top. There you go. So you put your fiber optic in here, make your connection there. Then you put your fiber optic in here. Now, please use this lanyard that's supplied with this thing. Now, I'll be honest, you know, Chris is about the boat guy. So he hooked it right here, which is it's made for that. When I'm out in the field, sometimes I'll put it around the wing nut right there, okay? Which as long as you get stress off of here, because you want some stress relief on that fiber connection, okay? So either connect it here or on the wing nut, I don't care. But use the lanyard that comes with it to help you on that, okay? You don't want problems there, all right? Then you just make your fiber connection here. So, and this, the fiber is what talks between the head unit and the base unit, okay? Now, when you get ready to turn them on, there's two different models, right? We recently had a change in the models. This is the older model. Any of you that have recently purchased one from us, you saw a newer model. We bumped up the rating on it from 150 kV phase to ground, so now we're 250 kV phase to ground, and we're 433 kV phase to phase. Okay, so when we did that, this screen came off, okay, to go to the higher rating. So I'm going to talk about both of them. I'll talk about the newer one first. It's just a green light here and a green light here down at the base unit. So what you'll get is the green light will come on the head unit telling you that you've got power, you've turned it on. You'll get a green light down at the base unit, tells you it's on. When you're measuring, it's going to start blinking, okay? And it will automatically turn off if you forget to turn it off. On this unit, with the screen on it, I'm going to first turn on. I'm going to turn on the base and I get 3 dashes. I'm going to come up here to the head unit that also has a push button. And when I press it and turn it on, you'll notice I've got a 0 with a decimal point. If I press it again, the decimal point goes away on the 0. What's the difference? When you hit it the second time and get rid of the decimal point, it gives you a longer extended line before this thing cuts off on its own. I got a battery in the base unit. I got a battery up here. I don't want either one of those to go dead in the middle of the field. So it's going to automatically cut off on you. You can extend that time that it stays on by hitting this button that second time and getting rid of that decimal point. Okay? Field trick. So you don't want to get halfway through the test and everything cut off. Okay? Another thing, you always face the label, my P-brain, this is the way I keep track of stuff, label towards the load, the two L's. The label goes towards the load. In this case, you can see that my current's going this way, so I'm going to have my current this way, label towards the load. Okay? You also have this line right up here. Okay? You want to try and keep your conductors inside of here. That's where this probe is most accurate. You get outside of here, things can start getting wonky on you. You want to keep it inside of here if you can. Okay? I also know that if you get a pole that is super tight and super populated, I got PTs, CTs, and it's all vertical, and everything's coming up like this, and I'm like, what in the world? Sometimes you got to turn this thing sideways and just barely get in there to where I'm not touching anything above or below. If I'm touching conductors above and below it, I'm going to get phase angle error issues, okay? But if I can turn this thing sideways and get in there where I'm not touching stuff above and below it, then it helps me out a lot. And also, you know, sometimes I have to cock this thing on here. Okay, I may need to cock the probe. Well, that's no problem. It'll work that way. Okay, so I can cock the probe. And then last but not least, I'll tell you, sometimes you need to back away. You want to get as close as possible, obviously. But if it's so crowded that you can't get in there and you need to back off to get a nice bare conductor to get on with this, do it. Okay? Because that's, if you get stuff, you're cramming up in a bunch of conductors, you're going to get phase angle errors. Okay? So, we're good to go on this test. So, we are going to go ahead and start the test.
Let's switch over to the PowerPoint real quick.
Okay, sure.
Show the
Oh, yeah. You've got some actual shots of some stuff. Okay, great. Yeah.
If you're looking at the PowerPoint here that Jarrett pulled up, this is an example of an actual substation we went out and tested using the high voltage probe. And this is the undercarriage of the station itself, and you'll see that the CT-PT combo is kind of inverted. And so the bus is kind of coming around up onto the conductor there. So like John was mentioning, you're mounting this probe right on the conductor itself as close as you can to the CT. Now, when you're at the substation, you can get on the line wherever you can, but it's always best to get close as you can to the CT. Next slide. So you can see here's a bit of a close-up where we actually can see where that the face is actually going towards the load, and this is actually somewhat of a clean installation where you're able to get your probe. In some cases where those CT-PT combos just have a lot of conductors and they're hard to access, you have to use a lot of the angles that the chuck adapter allows you to use to try to get in there on the primary line. And then once this test is over, this is just for A phase, so you have to move the probe from A, run the test, move it to B, run that test, and then move it to C finally to get all three CTs tested.
We're going to test the CTs now using the high volt probe. So I'm going to go to number 4, which is for testing CTs and PTs on my menu. I'm going to choose CT testing customer load. And we'll do burden ratio. I'm not checking double wrap because I am not double wrapping. Everything looks fine. Now, we've talked about this before, but let's talk about it one more time. The difference between using one probe and 3 probes. You could even use one flex if you want to. We have customers that use one flex. When you do that, you'll notice here at the bottom, see the difference where it shows my primary current connections? It's showing me I've got a solid green for my primary for A phase, because that's where I made my connection on my probe adapter cable for this, remember? I'm just on A phase. And it's just putting a green circle there letting me know I'm going to move it to B phase and then move it to C phase. Okay, so I'm connected on to A. The other 2 I'm not connected, but it knows that I'm going to move it B to C. You'd see the same thing if you just had one flex on A phase. Okay? So move probe to phase A. All right, and then you can hit F6. So we got a pass. So notice, label towards the load, right? Label towards the load. So, so all that was correct. So we got a good test. So I'm going to take it out here. We're going to go down to B. Nice. And then finally, C phase. I think y'all got slighted on that one a little bit. Is there going to be like a behind-the-scenes thing of this where we can show Chris with the little tripod in one hand and pointing with the other hand? It worked out great, though. It was pretty cool to watch that squat thing. All right, so we... yeah. Dude, you got a lot of work ahead of you. All right, so I'm going to hit done here. As we've done every time, we'll go ahead and take a quick look at recall data, number 8. And we'll page down and find bench demo. My tree diagram, come down, expand it on out. Let's see here. Load. Let me change the date on this thing, man. Cool. You just want to make sure that, I just recommend that, fellas. I mean, think about this. Before you leave, I mean, I would absolutely not want to have to go back to that site after doing all this. So go ahead and hit your recall data and take a look at your, make sure you got all your tests in there. You didn't fat finger something or mess something up, all right? So we went through testing the meter in a substation situation. So we opened up and provided all of our own voltage with the 7 series, right? And then tested the meter. And then also on the CTs, you got to use the high volt probe. We get a lot of questions about that. And now we will swing over to Chris Mullins, who's going to talk about a panel mount.
So John Jones was able to show what a typical socket-based meter looks like when you're at the substation. You got a nice, clean test switch that's wired in with the socket. So it's very, very similar to what you would find in an industrial application or a commercial application. But a lot of the substations you're going to run across are going to have these panel mount style meters like this. This is where you've got the meters actually inserted to a can like this, and it's got connections on the back here. And it's also, and on this case, this one actually has an integrated test switch. I was seeing that Martin was actually talking about in the chat area about in the cases where they do get an integrated test switch, you can actually do this where they can isolate here. So you can actually, this is integrated into the site. My voltages are isolated here, and then I've got my currents. And notice that these are very, very small duckbill style probes. That the probes that John showed won't work. So you're going to need something kind of like the smaller style, which is what we call substation style test switches. And those actually insert into these integrated switches like this. Pretty easy.
What's your mic?
No sound.
It's cutting in and out. Thank you.
Okay. Sorry about that. My mic was cutting in and out. What I was talking about were these panel mount meters themselves, and you can actually see the integrated test switch. In situations where you have this, you'll need a different style of duckbill, which is like this. So you can notice that the ridges are flat and they're a little bit thinner compared to what we generally have. And so those can be inserted directly into the current returns here. And in situations where you have to actually do a load box test, like Jones was showing, we also have very different style jumper leads. Notice these are much, much smaller than those easy hook style of jumpers that we showed on the socket-based meter. So those can connect pretty easy to here, so you can jumper across and be able to drive current into the meter itself. Voltages are fairly standard. They come over here and they clip onto the edge here, and then you can drive voltage directly into the meter. And with this, we have a suction cup mount that you can use for the magnetic pickup. And the thing I really like about the ion meters, which are now either Schneider or Square D, they keep on changing the name. But I also always like their meters that they have both the watt-hour pulses and the var-hour pulses simultaneously. So I don't need to worry about reprogramming once I do my var and watt-hour test. All I do is just move my pickup over and then run everything through, and it goes to really, really easy. Now let's say, for example, you have to actually take this meter out for maintenance. That's not a problem. All you need to do here is you flip the meter around, and like I mentioned, you've got all your connections here at the bottom. And there's a code down here at the bottom that talks about how these are measured. So V1, 2, and 3 are my 3 voltages, and my reference is going to be my neutral. So it's going to go red, yellow, blue, and then white over here for my reference. And we're going to tie our reference, our white and our green to the same point, and that's going to go to a true earth ground, either on the wall or somewhere where you can find a good ground. Same thing for our currents here as well. I11 equals A phase current drive. And you may notice, well, I've got a set of duckbills. How in the heck am I making connections to these current connections? Well, we also have these style of alligator clips where you can actually use that to be your current drive. So this is phase A. So here, the black lead here is your drive, and that's going to go to I1, which is number 4, over here. That just clips on. And then your white over your turn goes back over here to drive that. So you repeat that for each phase, A, B, and C. And so you're actually doing kind of like a bench test on a meter, kind of like how we showed with the CTs. So this meter is completely isolated. We're running both current and voltage. And notice also this meter has a separate power supply. So you will need kind of like one of those pigtails that has the hot, neutral, and ground tied here. And that goes to a separate outlet. So you've got one outlet powering off the PowerMaster 7 series, driving it, and then you have one outlet powering off the meter itself. This one doesn't have a KYZ contact, but on some cases they do. But most times you can just use this magnetic pickup and then go from there. Very, very easy. A lot of our customers handle it this way, where they actually separate the meter from the site and they actually go to the connections. But I just wanted to make sure that everybody saw that we can actually come into the front if you have an integrated test switch, and also if you've got some of those very, very old GE style where they have these slide-ins. You know what I'm talking about? Where they kind of, this comes out, they have these with these bolts on it and they slide in. We have adapters for that as well. Instead of having alligators, these are actually terminated with ring terminals. And you can actually mount those directly to that slide-in pickup to get your current and voltage isolated from the meter. Yeah, ABB and GE both make them. Yep.
What are the Ethernet ports for?
Communication for the, oh, you're on the PowerMaster?
Ricky asked, what are the Ethernet ports for? Ricky, could you be more specific, please?
Probably asking about if the Ethernet port's on the PowerMaster. If that's true, the Ethernet port is used for communication to our calibration system. So we have the calibration system called a PowerMaster 8901 or 8903, and it's connected via Ethernet to talk back and forth between the device and our calibration system. That's really the only main reason we use that connector. just for calibration only.
So we've been through 9 of these now. We were just saying this morning when we realized we couldn't believe it was that many. But we've really appreciated all the feedback we've gotten. I mean, we've gotten so much positive feedback on this, and we just can't tell you how much we appreciate that, because there is a little bit behind this. It's mostly Jared and Chris, but there is a lot behind this. So we really appreciate the feedback. And, if you would like, please take advantage of setting something up, okay? Set up a separate either training or demonstration for us. We can set it up just like this for your company and do them one-on-one. We don't mind doing those at all. As a matter of fact, we're hoping we do so many of them we get sick of it. So we'd love to have you line those up. So just give us a holler. Let us know. Remember, you're going to go on the Learn More tab is where you're going to set up a bench appointment, contact sales for all the other stuff, for test equipment, demonstrations, or training, or any of that, okay? Once again, we can't thank y'all enough for the feedback we're getting on this, and thank you so much for your attention. We had a lot of folks in this morning, and you guys just be careful out there, all right? Everybody be careful out there, watch themselves, and God bless y'all.